Hey everybody, welcome to another episode of Daily IoT. On today's episode, I'm not prepared. I gotta take the whole thing apart here. Let me unplug it. Stand by. We're gonna be talking about, wait for it, we're gonna be talking about the code that's running on the Trinket. I've got that all ready to go and smoothed out. It's all finished up. So we're gonna talk about what's going on this part. This is the dryer node. This is not part of it. This is my fat power supply that's been powering it. We're going to swap that out for the AC to DC converter, but everything over here is wrapped up, so we'll go through the code for that as well as the pull request that I sent to the RFM69 module on GitHub. So that is what we're going to head into now. We're going to start out in the Trinket code, the firmware that we are programming onto the Trinket that goes into the dryer. And let's just walk through this. As I mentioned, I'm using the RFM69 library, so we're including that header file as well as the AVR sleep header file, and we'll see what that's used for in just a minute. Then we have a few pound defines here for the network settings. The node ID, so the dryer is going to be node 2. Now if I had multiple dryers and multiple RFM69 modules, I'd give each one of them a unique node ID. Since I just have the one in the dryer and the one on the Pi, I only need 2 of them. The dryer gets number 2. The network ID is so that all of the nodes that are tied together know that they are connected through this network ID. They all use the same network ID, which I just arbitrarily set to 100. And then the gateway ID, so the RFM69 that is connected to the Raspberry Pi is node 1, and it also serves as our gateway. Okay, next up we have an encryption key. It needs to be 16 bytes, and so that's 16 right there, Daily IoT plus 1 through 8. And then I put in some helper code here because I did not check in. I'm not going to put my encryption key in the GitHub repository. Obviously, you don't want to do that. And so I will leave it commented out and empty, and then when you compile that for the first time, you'll get this error that tells you must define an encryption key and gives you an example there. So just a little bit of helper code. And then here are the RFM69 module settings for this module. It's the 433 megahertz version, and it is high powered. So I'm going to leave this is RFM69 HW HCW uncommented. If you have the low power version, you would just comment this out and everything would work just fine. Similarly, if you had a different RFM module that was at 800 and I can't remember, they are 815 megahertz or 900 and I can't remember what to do. There's 2 other frequencies, so you would just change this accordingly. Then we set up the RFM69 object. I'm just calling it RFM. And then here's the message. I've played around with a few ideas on this, but what I ended up going with was I'm going to send the MQTT topic and message so that the gateway doesn't have to have any knowledge that this is a dryer node. It's really just going to be a dummy forwarding service for our MQTT messages. And so I'm going to send it a topic and a message, and it will say, great, I'm going to send that message to that topic on the broker. So it abstracts away the dryer from the gateway so it doesn't have to have any specific knowledge about it. So that is the message that we will send. And then it's really pretty simple here. We have the setup function. We set up sleep mode, which we will call in a minute. This is just standard AVR sleep code. And then we have to initialize our RFM module with the frequency, node ID, and network ID. If it is high power, we call the set high power function. We encrypt with our encryption key, and then we're just going to fire a message right off. We're going to send it to the gateway, the message, and then the number of bytes in the message. We just do a strlen on message to send that through. And that is it. That takes care of it. That's going to fire that message off to the gateway, and it'll process it. As with all Arduino code, the next thing that's going to happen is the loop function is going to execute continuously, and so I just do a sleep. I just put it straight into sleep mode. There's really no reason that I have to do this. I mean, we're only going to be providing power for 5 seconds, so worst case scenario, it would just spin its wheels for a couple of seconds before powering back off. But better to be a good steward of power usage, so since we don't have to do anything else, we might as well put the Trinket back to sleep. So that is it. 56 lines of code with this, all this license and comment stuff up here. So not too bad, not a lot of code, and it does just enough to fulfill its purpose as the node inside the dryer. Now the other thing I wanted to show you quickly was this is the RFM69 code, the module that I imported into the Arduino environment, and I had to make some changes, and I told you that I had made a pull request. So we'll just take a look at that really quickly. We come to pull requests. Here's my add ATtiny support. I have not heard back from LowPowerLab on this as to whether they're interested in taking this or not. But I feel like I've done my duty as a community member and submitted the changes so that other people can benefit from it. We don't have to. The project succeeding is not based on them merging this in. We have the code that we need and we can move on, and I can provide instructions for people to use it. And so if we'll go over here to files changed, everywhere in the code where we included spi.h, I have now created a new file called rfm69spi. And all that does is, if it's an ATtiny, use the special SPI code that I wrote. Otherwise, just include the Arduino built-in SPI module. So that's a change that we've made in all the files that include SPI. And then there were also some functions in here that did serial output, which the Trinket does not have a serial port. The standard, it doesn't work with Arduino's serial.println like normal, like an Arduino Uno would. And so I've just defined a serial debug that I leave off if it's an ATtiny. So this will all work exactly as it did before for everybody else, except it leaves out the serial debug code for the Trinket, which is what we want. And then same thing here, we're just, instead of, there is no define of SS, that's slave select for the SPI. And so again, if defined AVR ATtiny85, that's the chip that's on our Trinket, then we just manually set the chip select pin to pin 3, which is what it is on the Trinket. And similarly, the IRQ we need to set for our case of the ATtiny, take care of that. And then here's where, as long as we haven't defined ATtiny85, go ahead and define serial debug, otherwise leave it off. Here's another one of those SPI to RFM69 SPI changes. These are all very similar changes to what we saw before. Again, oh no, sorry, this is a little bit different. This OTA, this RFM69 OTA, I'm not sure that the Arduino environment compiles files that you don't even need. It tries to compile them even though you haven't referenced any code in them, which is a little annoying. And so even though I'm not using any of this RFM69 over-the-air code, Arduino says, I'm going to try and compile that for you. Oh, you don't have any of the serial stuff or all this other code. We will never do over-the-air updates with the Trinket. It just cannot handle it. And so I've just put a big pound not defined ATtiny85 around that entire file. Same thing for the header file. So we don't include any of that over-the-air code for our Trinket example. And then finally, here's this RFM69 spi.h file. I got some of this code from the Arduino Playground. I also got some of it from, I put some attribution in here to Jack Christensen for his tiny SPI. And this is really just the hardware SPI on the ATtiny, which is what our Trinket uses, so that we can do hardware SPI to communicate with the RFM69 module. That's what all this code does. I'll let you look at that if you're interested. And then, like I said, if it's not, so in this else, if it's not an ATtiny, just include the normal SPI.h. So that was really all it took to get the RFM69 module working with our Adafruit Trinket. All right, that's it for today's episode. And so coming up, I've got a little outline here that I've put together. We're going to go over some basics of MQTT. For those that aren't familiar with that, I can just talk about that a little bit and how I understand it. I did get LowSont working, MQTT, the MQTT broker through LowSont working. Actually had some of this stuff communicating all the way through the loop here in the background, so very exciting. I'll step through how we got that working. I do want to talk about how I set up the Pi. It's not very hard, but there's some things that you have to do to get the Pi up and running. And yeah, those are kind of the episodes that are coming up. And so stay tuned for those. I appreciate everybody watching. I almost finished up without going into question of the day. Ooh. Again, why don't I think of these things before I turn the camera on? All right, so I got a pull request out with LowPowerLab. What is your favorite open source project that you have used over the years? Favorite open source project? Stick it in the comments. I appreciate everybody watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.